Good evening, everyone, and welcome to Sky Observers Hangout. My name is Michelle. I am the Director of Public Observing at the Adler Planetarium here in Chicago, and we're coming to you live from the Adler's Doane Observatory, and I have a friend joining me tonight.
Yes,
Hello.
my name is Hunter, public observing educator here at the Adler, and I gotta say, it is lovely to be back in the observatory. If you were with us for the last show.
And we're not wearing hats and coats.
That's true, this is the first warm show out here in a
15
while.
hand warmers in our pockets.
But if any of the folks online are frequent visitors of Sky Observers Hangout, they'll know the last show was quite special, our eclipse show. But it's great to be back to our usual cadence here in Chicago, observing with the Doane telescope, right?
So, Sky Observers Hangout, this is your first time with us. Welcome! It's our time to gather together to nerd out about the sky. If you just want to sit and watch, that is totally fine. But if you'd like to interact with us, please do so in the chat. And we've got some friends joining us there. You can send us questions, you can send comments, you can answer other people's questions. It is totally fine to do that. So I'm just going to tell you, because we got a couple friends joining us there who are kind of helping us out.
Yeah, we've got some folks helping us out online. So if you see the Adler Planetarium's account in the chat tonight, that'll be our coworker Jennifer, who will be chat moderating today, passing any questions or kinds of comments that you guys make to us tonight. And then also, if you see Geza in the chat, one of our astronomers here at the planetarium, he'll be helping answer some of those, let's say, more hard-hitting questions, the ones that maybe require a nice, really long explanation. He'll be there in the chat helping us out when we need that.
Exactly. So, Jennifer has put a question into the chat. If you missed it, or if you just joined us and you missed it, tell us where you're joining us from. We'd love to know. We're going to give you a shout out if we can. So please, in the chat, let us know. She's telling us behind the scenes where everyone is. So,
yep. I see we've already got somebody joining us from Wisconsin.
Hello.
And if you want to make sure that you can be here for the start of all of our live streams in the future, don't forget to subscribe down below. Not only do you get all of the wonderful sky observing content that we do, but also, a huge plethora of stuff that's coming out of the planetarium. So it's a great follow for sure.
Exactly. And if you like us, hey, give us a thumbs up. It actually helps people find our show, find the Adler Planetarium's channel as well. So we got a lot of other cool stuff on the YouTube channel.
For sure. Yeah. Well, I think we should get right into it. The clouds are starting to clear up a little bit. For anybody that's joining us tonight, I will give a warning that it maybe will be a little bit of a touch and go show. It's very likely that we'll be going off script tonight because we are dealing with a few clouds that could get in the way from time to time. But whenever those clouds are clear, we are definitely going to try and take advantage of it. We've got a screen over here that shows us the live view of the telescope at all times. And right now I'm noticing it's very dark.
Yeah, so if you see us looking over here, it's because, switch over real quick.
Oh, there you go.
Yep. There it goes.
Oh,
wait.
It's still just there, yeah.
There it is, there it is. All right.
You can definitely see the clouds making some of our views go in and out. So we'll do our best to show you as many live views as we can tonight, but certainly tons of interesting content to go over. Now, I see some more comments. Lots of Illinois folks.
And someone says, my hair is fantastic. Thank you. I'm having a good hair day. Did I not say about 45 minutes ago I was having a good hair day?
You did say it about 45 minutes. I will say, after you said that, I commented that I thought I was too, but apparently not good enough. Apparently not good enough.
Please tell us if Hunter is having a good hair day. That would be great. So
yeah, I got Tim. I'm sure Emma's in the chat, so if she doesn't type that in the comments, I'll be disappointed.
Or your parents.
Or my parents.
Or your parents.
Them too.
All right, so what are we talking about tonight? Right now, we're actually showing a black screen.
Right, sorry, I forgot that was still the main screen. So our main focus for tonight is going to be a lot of accidental puns might come in.
Go ahead.
But our main focus tonight will be, an object that's a little bit tougher to spot in the night sky, something that you can't see with the naked eye, something called globular clusters. You might have seen that in the title of the show today. But one thing that's notable about those is that they're rather hard to spot. And so especially we're waiting for darker skies and slightly more clear skies before we can shift to talking about those clusters. But because they're so full of stars, right, and to give a little bit of context when we talk about some of the numbers that we hear with the clusters later, You can tell the clouds are clearing. It's a nice bright star now.
Yeah, definitely.
We wanted to start off with a couple of closer individual stars, right? So, Michelle, what star are we taking a look at right now to start us off?
This is Spica. There it is, right there. So, since these globular clusters contain old stars, we want to go the other direction. We want to show you a young star. Spica is a blue giant star. Now, the color of the star tells you its temperature. So, yes, in astronomy, we love confusing you. So, unlike your water faucets at home, where you're used to seeing the red dot for hot and the blue dot for cold, stars are the opposite. Stars, blue is hot, red is cooler. So the star Spica is a blue giant star, so it is a very hot star. Again, if you're just joining us, we've got the telescope pointed live with a camera on it right behind us, right here.
Yeah, you can tell it's live by how much the star's going in and out. And you know, I wanted a good, I think, comparison when we talk about star colors, and I think what helps kind of solidify it in people's heads, which ones are hotter, which ones are cooler, is really thinking about flame. Sitting at the campfire is what I always think about. I feel like it's something that really enchants us, right? When we think about the colors we see in there a lot. You see those blue or white, you know, kind of flames closer to the center where you have those hot coals, right? Those outer flames becoming more orange. Very similar to what we're experiencing when we're looking at these stars.
So these massive, these giant stars, well, these blue stars, blue, white, white, they go through their fuel faster than kind of the medium-sized or medium-mass stars like we have here for our sun, and they just don't last as long. They burn through their fuel quickly. So our sun is going to last many billions of years. Spica is, well, it'll explode as a supernova someday. And how old is Spica?
I think right now it's only about 10 million years old.
Give
you some context. We're into the billions for our sun, and it's kind of middle-aged, right? It's right about the middle of its lifespan.
Yep.
This is 10 million years old.
Yep.
And you know, we can see how bright and it's burning.
I think we have to say, we got to say
but
hi to somebody.
I did see Haven, the special shout out here in the chat. First trip to the planetarium a few weeks ago, and tuning in tonight. That's great. That is very exciting. It's great to have you here. And he asked a question: how big is Spica?
Oh, Spica. Spica is bigger than our sun. So I mentioned it's a blue giant star. So it is actually starting to get toward the end of its lifetime. Not at the very end. It is not going to explode anytime soon. Don't set your watch.
No, and in terms of, you know, still
stars,
many years beyond our lifetime.
Yeah, a few more million years for million with an M for Spica. But the star Spica is bigger than our sun. I think Geza helped me out.
I can look it up really quick.
I didn't write that one down. Actually, we're looking it up right now. I think Spica is about 7 times the diameter.
It's nicely done. 7 to 4 times our sun's diameter. Very nice, very nice.
And I did not read that. I actually thought it, and then he looked it up right over here. So anyway, all right. So yeah, so we've got a blue star. Now, it might be a little hard to tell that it's blue. I'm going to take advantage of the fact that it is
we've got it pretty nice and bright right now.
So
one trick that we like to use is when you defocus these stars, oh yeah, look at how clear that was quickly. You can really start to make out some of those different colors a little better as it's spreading that light out. When they're concentrated on that one little point, I find that they often look mostly white.
Yep.
But when you spread it out, I mean, you could see how much bluer that appears when the clouds aren't in the way there. Yeah,
is that
look
cool
at that.
Or what? Oh, I love that. That is my favorite thing to do at the telescope. I know that is really weird. That as much as this thing costs, my favorite thing to do is to defocus.
Yeah, it's the opposite of what we're usually trying to do, right?
No.
But it gives a really good lesson here. And honestly, maybe we should leave it like this as we switch to the next target.
Yeah,
and as we switch to the next one, I want you all to think about this color comparison in mind. And let's see how different the next star looks.
Okay.
Oh, you know what I want to do while we switch? Guys, we've got anybody who's joining us for multiple occasions today. We've got a special new view today. Telescope camera. You can watch the roof move behind us.
All right, so I'm gonna move the roof. Here we go. Actually, I'm gonna move the telescope first. All right.
So you'll see behind me and in that other camera, so the telescope is tracking on its own, it moves on its own. The roof's a little older, we'll spin it on our own, so apologies for the sound. Great. Well, that was so fun to see on the other camera, guys. I am so excited about this new view that we have looking out the window. You can still see a few clouds in the way, but for now, we will switch over to our telescope camera. And keep an eye on things and as it comes in and out of view. Yep. But we can start with a little introduction on what star we're looking at. Yep. And then as it starts to come into view, think about the comparison more. So what's this one that we have?
This is Arcturus. Arcturus is a very bright star. It's the fourth brightest star in our summertime sky here. So it is called a red giant star. Now, despite the name, it is not red, meaning it is not red like we think red like a stop sign. Right. It is not that red. It's more like orange. But
still quite distinctly different from the very blue-green Spica that we saw earlier.
And so we're just waiting for
cloud update. Oh, there's the cloud still in the way.
Yeah, that's all right. And Hunter's really enjoying the fact that he can switch over between those two.
I'm loving the other camera.
We're so easily amused here. Arcturus is a red giant star. It is bigger than our sun also. It is nearing the end of its lifetime or getting closer, but it is cooler than our sun. So it would be that orange or that red color. Now, it is a lot older than Spica. Cooler stars don't go through their fuel nearly as quickly as the hot stars.
So it doesn't necessarily tell us that it is old, but it does maybe tell us that it will have a longer lifespan.
Yeah. This one probably started out similar to our sun, maybe a little bit more massive, maybe a little bit hotter, but it is getting closer to the end of its lifetime, and so it has expanded to form a red giant star. So it probably, I'm gonna guess, it maybe was a yellow star, maybe yellow white, but it has expanded, cooled on the surface, and now it is a red giant. So,
and as it comes in and out of view, folks online might be paying closer attention than we are. I think I can particularly see, we're looking through some clouds, so the colors might not come through too well. Yep. But at the very least, I could see some of those warmer tones, maybe moving into some yellows and things that I'm noticing.
Yep.
Now, I also wanted to give some extra context. I don't know if you had said the particular age of this one. This one living up to now 7 billion years that we're looking at here, right? And again, it's more similar to our sun, which is moving into that 4+ billion year old age that it's at now. So we can start to see the range that these years can last. Another thing I wanted to point out is how distant these stars are from us, because these ones are really pretty close in the grand scheme of things. So Arcturus, just 37 light years away. Really, when we get into outer space kind of numbers, that's not so far. And I want to give that 37 as sort of a preface when we get to some of these much vaster distances that we'll be looking at with some of these other objects tonight. And so that 37 light years is really pretty close. Spica, a little further away, looking at maybe more like 250 light years away from us. But
meaning the light that we were seeing through the telescope, and hopefully we'll see soon when the clouds are moving away, left Arcturus 37 years ago. The light left Spica, what was it, 250 years ago. So
actually, I was going to say, since we've got some clouds right now and we're talking about the distance to Arcturus, it's actually a very opportune time we're running this in a little bit of a different order than we planned to work with the clouds. And actually, before we get to this, we do have one question in the chat that's a good one. So somebody was saying, so Spica is actually a binary star, right? We only see it as one through the camera, but through some more complicated techniques like spectroscopy, where we're able to sort of split the light and look at these very particular wavelengths of light we're receiving, we were able to determine that it's actually two stars.
Correct.
And it's a very, very close binary, which is why we can't split it. They are orbiting each other, these two stars, in just 4 days. Right, so you think about how long it takes the Earth to go around the sun, right? That's a full year, 365 days. Oh,
There we
that's
go.
a great view. There we go. Look at how vibrantly yellow and orange that is.
That's cool.
So much different from Spica that we were looking at before, right?
You know what the fun part is? Now I have to try to refocus.
Now you gotta refocus it, yeah.
So I'm reaching right here. So if you're wondering if this is live, this really is live. I'm turning a knob.
But a good follow-up question to this
Yeah.
about Spica being a binary, and I'm honestly not sure about the answer to this. Can we tell when they eclipse each other from here on Earth? I'm not sure. Can you tell? So, to give some context to this, if a planet passes in front of a star, no problem, we can see that sort of disruption happening. That is how we detect a lot of exoplanets. That's the transit method. When it's two stars, though,
I think so, and Geza will need to help us out again.
Yeah,
with
that
this
might
one.
be a Geza
I
question.
think so. I think an eclipsing binary, the spectrum would show up differently.
Would change
I don't
differently.
know what the difference is. So that's
Very
a really good
interesting.
question. We'll have to look up more about that.
Yeah, I'm sure Geza will give a great answer in the chat. And another thing to remember is, even if these two stars are orbiting each other, the plane that they are orbiting around each other may not align with the view that we are getting at that star.
Well,
So-
if it's an eclipsing binary, it would be.
Right.
But if it's
They were
not-
saying
if it isn't.
this was a theoretical, yes,
Right,
if they were eclipsing each other. I'm not sure if these are an eclipsing binary. or
Yeah, I'm not sure.
Very good question.
Yeah.
Very good question.
So Arcturus
we do-
has a special tiny bit of history with the Adler Planetarium.
Yes, so it's honestly been a while since we've had a really good focus on Collections Corner, but we're still kind of waiting for it to get a little darker before we switch to the clusters. So this object is a photocell. You might be wondering, okay, we got to figure out how this connects to Arcturus.
Yeah,
a
why are we showing a
photocell
box?
used during the, make sure I get my year right here, 1933 World's
Correct.
Fair.
Correct.
Here in Chicago, and there's a very particular relation to Arcturus here, and it has to do with that distance away. Now, one thing that's important to note, at that time they thought it was 40 light years away, so that plays a very important role here. So the idea at the World's Fair was they had another World's Fair just 40 years prior in Chicago, the Columbian Exhibition, right? And when they had this, they were planning the new one. They said, all right, how can we connect to this prior event that we did? And they thought, well, you know what? Arcturus is 40 light years away. Let's open the ceremony, light the grounds using light that left its star 40 years ago when the last one was happening. And so this exact photocell was one of there were a few of them that were set up at different observatories, some very close to the World's Fair, some spread out around the state and even into multiple states. But this was one of the ones that collected light from Arcturus, like we just looked at, and on this big rostrum that opened the ceremonies, we can see the light of Arcturus from 1893 traveling all the way here to us in Chicago.
So there is a tiny little bit of World's Fair controversy related to these photocells and all that. The weather reports are that it was cloudy that night.
Very well.
How did they turn up? Well,
That
okay,
is
so-
theoretically why they had them
Right.
in many areas.
Right, including the Hercules Observatory, and
Yep.
I think there was one nearby.
Yes, so they
And-
actually added the one nearby kind of last minute, just in case they couldn't get the feeds from the other one.
Yep.
It didn't really work out
But
very
if
well.
this, I wonder, was this the opening of the actual opening? Of
I
the
don't know if this is from the actual opening, I'll be honest.
I'm gonna say I see some clouds.
There are some clouds in the background there for sure. Should have grabbed a picture from opening ceremony day. I even had one, but I really wanted to
that's
highlight the
all right.
rostrum. So
That's pretty
just
cool.
a fun little connection that we have here at the planetarium to the star Arcturus
Yep.
that we were looking at tonight.
And the Adler
see a
Planetarium
cloud
was
up.
on the grounds of the World's Fair. So the fair surrounded this whole area, Northerly Island, and this whole environment was part of the World's Fair grounds. So so we had a lot of people coming through at that point. So
It's an interesting connection.
yeah, would have been
All
neat
right,
to see.
well, I think that it's clear enough that we should give it a shot at our
my
first
goodness,
cluster,
yes,
because it
we
really
should.
is clearing up behind us.
Okay.
We'll give them a quick view. Wow, look at the beautiful clear
Wow, that's
sky.
cool.
Wow.
All right. So what I'm gonna do is I'm gonna go over to the computer, click on. Let's see, which one would you like first?
let's start with M3 because I know that
M3?
that part of the sky is clear. So one thing that you'll hear from us tonight quite a bit is referring to these by their Messier catalog numbers. So this was a catalog of essentially fuzzy objects in the sky that were compiled by an astronomer whose last name was Messier, Charles Messier, back in that was the 1800s, yes, Michelle?
Late 1700s.
Late 1700s. He was compiling all these objects actually because he was really looking for comets.
I need to move the room.
Moving the room. He was looking for comets, and all of these other objects were kind of disturbing his chase for these comets. What that ended up doing was creating a wonderful catalog of these kinds of dim and more diffuse objects. Basically everything that wasn't a solar system object or a star. Wow, that looks great. Now I'm going to switch to it immediately because it looks so good. So,
A little bit out of focus.
you will hear us refer to these by their Messier numbers tonight. So this one is known as M3, Messier 3. Quite an early one in the catalog, and we're kind of doing these by altitude tonight. So the stars that we looked at earlier are very bright stars in the sky, things that you can totally see tonight with relative ease. Even from here in Chicago, you can see them naked eye, no problem. These globular clusters are a little bit more difficult to spot. Here in the city with a small telescope, you could make them out, but they'd be difficult to spot. Seeing so many stars resolved, having a big telescope like the one we have behind us really helps a lot.
Look at how good that looks.
Looks really great. It looks really great for how early it is. Yeah. So the views should get honestly even better as the night goes on.
I'm gonna take a quick snap.
Yeah, no worries. Is that a live view and the sky is just really still, or is it?
Yeah, that is a live.
Or is it in
view.
place? Was it an image?
Yeah.
Wow.
Yeah, that is a live.
Very
that is a
still
live
skies.
view. What I have to do is increase the exposure time of the image so it doesn't refresh as quickly as the star images
Right.
were, because we're taking a picture every about 2.5 seconds, as opposed to when we had the stars. They're very bright, so we were taking a picture in well under a second for those.
Yeah, this is an important thing to note is, right, like not only are we using a large aperture, we have a camera on which already can collect more light than our eyes are, or our eyes do, and then it has an extended exposure time. This is, you said about a 2-second exposure right now.
Yeah.
Our eyes only sit at around, technically it's like once or 30 times a second, I think. It's a 30th of a second is the comparison you could give, but it's not a very exact one. Cameras have a lot more capabilities than our eyes have.
By the way, the picture will be a tiny bit blurry. It is a little bit windy tonight, so we're dealing with that. But I'm shocked at how good this looks, considering how cloudy it was about half an hour ago.
Yeah.
So this is really great.
Really lucky with when the clouds cleared tonight.
Yep.
So we've got a globular cluster
Yep.
in our sights. We can, the folks online can see what they look like.
Yep.
But I think it would be helpful to give a little bit of a breakdown of really what's going on here. What are we looking at? What is a globular cluster?
So a globular cluster, first off, stars come in groups. We call those clusters. There are two main types of clusters. Open clusters, which are just clusters of stars. They don't have any particular shape. And globular clusters. And you can think of the word globular as globular, round-ish. So these are large, spherical-ish groupings of stars. They can contain anywhere from a few thousand stars all the way up to millions of stars.
Right.
These are huge groups of stars in terms of numbers. And in our telescope view, we're seeing the central part of this particular globular cluster, which is M3. And
Yeah, I actually checked. I think I looked at I believe it was for this camera, what the field of view is for this camera. And I think it was about 20 arc minutes, and we're looking at, these are just a little bit wider than that, maybe about 25. So we're close to the edge, but the core is really where you have that densely packed. I mean, you can even see how it gets more dispersed as we go outwards. The core is the exciting part.
So just to explain, about 20 arc minutes is about a third of a degree in the sky. So about less than a little bit less than a quarter of the diameter of your thumb held out at arm's length.
Right, so a pretty small field of
Yeah.
view that we're looking at up in the sky with this, and these clusters essentially fill that field of view.
Yep.
Now, we were talking about some of these numbers earlier, things like how far away these are, how old these stars are, and so I think it's nice to get right into that, right? So earlier we were talking about Arcturus as being, 37 light years from us. Now, before we talk about how far away this thing is 680 light years wide. Just the cluster itself is that wide, and it's over 30,000 light years away from us here on Earth. So while we can make out some individual stars in here, they're so much more distant than some of these other bright ones that we see in the sky that are pretty close to our little section of the universe.
So think of it this way. Take a look at the image on the screen. By the way, this is live, so if you're seeing it updating, that's because it's taking a picture every 2.5 seconds. And if a cloud goes past,
you can see some little clouds
it's
getting in the
cutting
way,
down
yeah.
on the light. So it really is live. So imagining the size of this cluster. Look at one star on one side of the image and another star on the other side of the image, and imagine those are about 600 light years apart.
Right.
So if you're at one side of this cluster, the light from the star at the other side of the whole other end of the cluster took 600 years to get there.
Just remarkable.
You can't
Just
see
remarkable.
this. If you were there, you couldn't see all the stars as they exist right this very second. It is that big of a cluster.
Yeah, it's hard to even still for me imagine the scale of these kinds of objects. This one in particular, 500,000 stars in it, formed almost 11.5 billion years ago. It's a scale that is really tough to imagine, and at least you have some of these other comparisons to look to. But I think they really only go so far in comprehending these kinds of huge numbers.
By the way, if you're seeing a little bit of a darker donut on the screen, that is a piece of dust.
Yes.
And that dust is on the telescope mirror because we see it in in all of our images. And you know what? If we've got some dust on the mirror, doesn't matter. It's okay. We're not going to clean it. So
we'd rather have one speck of dust than one big old scratch from
Exactly.
getting that speck of dust off, right?
Yep.
And you'll notice we really only see it right now because clouds are in the way, right?
Yep.
And it is brightening what would be the background. And actually, this is a good opportunity to talk about some of the other kinds of images that you see out there related to astronomy, and how there's a little bit more than meets the eye, right? So when we are taking images through this telescope, we're actually able to remove that dust ring, right? By doing lots of other images where we put the cover on the telescope, and that shows us, oh, well, the ring's still there, even though there's no light being brought into the telescope itself. These things start to help us reduce the images, take some of this stuff out, and that is what makes things like, I'll switch to this briefly, images like this possible. This is taken from a ground-based telescope. This isn't from Hubble or anything. Certainly this wasn't taken from in the city, right? They're from a much darker sky, but it's many images overlapped together. They're reducing the noise by, essentially canceling all of that stuff out. There's a lot of techniques that go into telescope imagery, and so I think it's a good thing to note that these are the images that we often see of globular clusters. This is what our camera can see right now, and on a really, really clear night, you could see maybe a quarter as many stars as are on there right now, maybe less with the eye. And that was like recently with the best seeing conditions I've ever had on one of these things. And it comes close in your head, but if you really sat there and counted the stars, it would be so much lower.
Do we want to switch and see if we can get another one of these?
Yeah, I think let's give it a shot. We'll switch it over. Try out
what would you
M13
like?
next.
M13?
I think so. Yeah, let's go to the big bright one next.
All right. As the clouds move.
Well, the clouds are coming that way, but that might mean that direction is nice and clear. So we'll do another view of our telescope moving, because I'm so excited about the other camera being there. further. A little bit. Good. All right. Yes, great. So the reason we have to do that, and why I also needed to get up to help, is while the telescope is tracking objects in the sky, because it's quite new, just installed pretty recently, only a few years ago. This is the original roof from 1977 when the observatory was constructed, so it doesn't move on its own. We don't have to get up and push it or nothing, but we have to press the button at least. And people always get a kick out of this. It's actually powered by go-kart tires. Just little go-kart tires.
All right.
Well, it seems we must have found a bit of clear patch here.
A little bit.
And I think it's interesting to note, one thing that I really wanted to try and do with the show today is, as we look at some of these different clusters, comparing them, seeing how they differ, because just like each star is different in its age, how hot it is, how big it is, same with globular clusters. They can vary a lot, and I noticed that they especially vary in the way that the stars are distributed throughout. So a little tough to notice right now, but we'll see if we can make that difference out here. That's a nice freeze frame of it there. So one thing that I particularly noticed here is on the last one when we were looking at M3, we saw that it had this really, really compact and bright core. In this one, I notice, doesn't feel quite so packed in right in the center, but rather that the stars are dispersed out a little bigger, and it feels larger in the field of view. I can see more bright stars all around that outer rim of the field of view, whereas it was a little sleepy on those outer edges in the last one.
And I'm also going to, once I can see it
Once you can see M13 again, yeah, exactly.
I'm gonna try to center it just a tiny bit more. Let's see, there we go.
Now, this globular cluster, this one's number 13 in the Messier catalog. This one's one of the more famous clusters. You could tell because it actually has its own name. This one is actually a few different names. You can call it the Hercules cluster, the Great Hercules cluster, some combination of those words together. And so that tells you which constellation this lies in. This is in the Hercules constellation.
By the way, if you're wondering what we're using to move the telescope, it is this right here. So I actually can let's see if I can do it without messing this up too much. Oh, of course it goes.
Yeah, well, that's how it goes. We've gotten some good views in between. So this one is one that, especially here in the Northern Hemisphere, is very easy to spot. It's high in the sky here, it's very bright, and especially has a lot of bright individual stars. I think that's what I noticed the most on this one. Now, saying that, while it is, trying to get it back the right direction.
Yep.
There we go. It's always confusing. The mirrors in the telescope switch around the directions that it moves when you move the stick. It always throws me for a whirl. But yeah, so this one is one that's very common for observing here in the Northern Hemisphere. There is one that is significantly brighter than this that is visible from here on Earth, but not visible to us here in the Northern Hemisphere, just down in the Southern Hemisphere, and that one's even pretty noticeable with the naked eye at a dark site.
If you go far enough south in the Northern Hemisphere, you can see it.
Nearer the equator,
the Omega.
Omega Centauri.
Omega Centauri, yes. So.
And so that one's a little bigger and brighter than this, but we can't see that from here in Chicago. And this one is still just so dazzling. But even though it's brighter from here, and there are so many more bright individual stars that we can make out, it's important to note that what we observe from here doesn't necessarily tell us so much about the object that we're looking at. A lot of other factors come into play, right? So while this may look bigger and brighter to us here, much smaller, only 145 light years across versus that 680, right? We're looking at just a quarter of the width. But it is a little bit closer, only 25,000 light years away this time.
So the light that you're seeing right here, this light right here, in this image, which is live, taken with this telescope right there, with that camera.
With the blue camera, with the little blinking light. Yep, you can see it.
Left those stars approximately 25,000 years ago.
Remarkable. Yeah. And this one otherwise is pretty comparable. It has a similar number of stars. Now, the number of stars that we have in these is very much an estimate. You'll see really big ranges. M3 in particular is one that we have a more accurate number on, we think, at least, right? There's nobody sitting there and counting 500,000 individual ones with their finger out, right? And marking each of them off as they go, right? This one, it's more of a range, 300 to 500,000. So these can be pretty big ranges that we're looking at when we're talking about some of these objects. And that's because there's quite a few of them out there. You know, we already have discovered, 150 orbiting the Milky Way, and maybe even more that are out there that are, obstructed from view by, say, the Milky Way's core or something like that. Yep. So there's so much out there, and I love looking at the Hercules cluster. This is one that I think is particularly exciting through the eyepiece.
And if you come and visit us at the Adler Planetarium on Wednesday evenings, if it is clear out over the next few
let's say
weeks or
it's
so.
definitely at least a few weeks, if not another month on M13. Though I will say the next 2 weeks we're probably looking at the moon because it's up.
Yes.
And the moon makes it very difficult to observe these kinds of objects when they're near each other because it is so dim. Actually just made that mistake about a month ago, learned my lesson, tried to look at it on a full moon night. It was so hard to see.
Yeah.
Really, really tough to spot, even knowing what to look for.
So the light pollution from the moon can cause these to be a little too dim to be able to easily see them. So we base what we point the telescope at on a Wednesday night, if it's clear, based on what will look good. So sometime in July, when the moon is, or late June.
Yeah, even late June,
Yep. When the moon is out of the way, then you might see M13 through our telescope with your very own eyeballs.
Absolutely. Again, we got to wait until it's a little darker, so it's about the last maybe half hour of our night out here. But
that's right.
It is always a joy to look at and dazzled me every time. And I've been making the comparison recently. We've got the fireworks over at Navy Pier across the water at 9 o'clock that you can watch. And then you can come see nature's fireworks. Not quite as active and moving as maybe the ones that we see at Navy Pier.
Right.
But, I'd say a similar view to a freeze frame of a firework through the telescope.
That's right. So these globular clusters are interesting in where they are located. Should we show these folks?
Yeah, actually that's a good point. And as we're kind of clouding up a little bit on this one, it's a good mention because you'll notice we've got lots of globular clusters tonight. We're talking about how we're observing them, here on Wednesday nights as well. And so there's a very good reason for that. This really is globular cluster season, right? We've got tons and tons of them in the night sky. And that is not by chance. What is it about this time of year that makes it easy to spot a lot of globulars?
Well, why don't we show the picture of the Milky Way here, all right? So this is a picture of our Milky Way galaxy as seen from Earth.
This is taken by the Gaia telescope project.
So the Gaia telescope is located in our solar system, not all that far away. So we can't see our galaxy from the outside in. We just can't get our telescopes and spacecraft and all that far away. So our galaxy is fairly flat, like imagine a fried egg. So you've got the egg white. We live out in the egg white, and then there's a bulge in the middle. That'd be like the egg yolk. So we've got a spiral or a pinwheel shaped galaxy with a bulge of older stars in the middle.
Right, and I think this picture demonstrates that really well, right? The kind of bright line that you see across with lots of all that light being these different stars that are in there. Very bright central core here. So you can imagine the kind of plane of the galaxy that we're seeing in the sky. Right?
So where we're looking right here, toward the center of that picture, if you go out in the later summer and you go out in the early evening, you face south and you look about a third of the way up in the sky, you are looking toward that direction. So you're looking toward the center of our Milky Way. So the globular clusters don't orbit with the spiral arms, they orbit around the center, all around. And so you're going to want to look for them, in this case, in the spring. So when we're looking kind of up a little bit above the center of the galaxy, when we're looking toward the south. So, or toward the east. So here in Chicago. So that makes it a little easier to find them in the springtime sky. So
exactly. So here on the map, you can see I overlaid each of these yellow dots indicates a globular cluster. We have many more, but I exhausted the number of dots that I wanted to put in there, and I thought that this was a pretty good representation of it. These were actually all visible globular clusters in the image.
And we were trying to figure out, why did they use blue dots?
I know, yeah, you can see the blue dots in the first image, and actually you can still see a couple of blue dots in this one because there are a couple of open clusters indicated on here. I think this is the Pleiades way over here, all the way on the edge. But yeah, so you can see that they make this kind of big sphere around the galactic plane, right? Orbiting around the core. And I think this image demonstrates very well, you imagine, all right, this part is straight up above us in the summertime.
Yep.
Well, here you go.
It's toward the south, and that part's toward the south in the summertime. Yep. And
so we can see this in the summer. Well, right now, we're looking at all of this stuff along here. And then let's say after Milky Way season in the fall, we'll get another opportunity to see a few more clusters. Though, especially here in the northern hemisphere, a lot of the globular clusters that we want to see are in the springtime. So this is kind of our cluster season. We have a lot of this based on really the organization of the galactic plane and where Earth is pointing at different times of year, right? In summertime, we get the opportunity to look at a lot of interesting objects within the Milky Way, right? Things like planetary nebula, other stars, globular cluster season on the other sides of it. And then in the winter, when we're looking more outside of the Milky Way and some of those seasons, we see a lot more galaxies, other galaxies when we don't have all of the local galactic stuff in the way.
When you're looking in the opposite direction. So
exactly.
we went back to our live view of M13.
Yeah, sky started to clear, and I just can't bear to keep you from viewing M13 while we can see it, because it just looks so nice. Now, one thing we have talked about today, especially earlier when we were talking about the ages of the stars, was how old these stars were, looking at 10 million years, 7 billion years. One thing we haven't talked about so far with these globular clusters is what their ages really look like. I mean, maybe I mentioned it briefly, but there's so much to unpack when we start thinking about the age of these. So, I mean, we're looking at over 11 billion years old when the two of these formed, right?
Yep.
About 11.5 billion years ago for each of them.
Yep.
What did this part of the universe look like at that time? What is going on when these globular clusters are forming?
So globular clusters are leftovers from potentially other galaxies that collided with our own Milky Way in the past. So you're looking at the remnants of other galaxies that themselves no longer exist. And we've absorbed those stars into the structure of our Milky Way. And so that can studying the globulars can sort of give us a bit of information about maybe galactic evolution over time. We weren't around 10 billion years ago, 7 billion years ago, 11 billion years ago, so we didn't get to see this. So we have to kind of piece this together by studying their orbits and what they're doing and how they are in relation to the Milky Way, but also by studying other galaxies.
Right, we're getting to the point where we can see globular clusters around other galaxies, not just our own.
Exactly.
Which has definitely helped to grow our understanding of them quite a bit as we have these, more advanced telescopes that are able to image these even dimmer objects, right?
But in these globulars, you're going to have the older stars, the red stars, the orange stars, maybe some yellow stars, some red giant stars, stars that have that are starting to reach the ends of their lifetimes. You're generally not going to find blue stars because they X'd out a long time ago.
Right, so many of these stars did form, in those early stages. There is some evidence now that maybe there's multiple stages of star formation in globular clusters. Originally, it was kind of thought that it was just all at the beginning. It still seems like it's at least concentrated in the beginning, and many of these are forming at that early time. And to give you some perspective on that age, we're looking at just 2 billion years after the age of the universe, really, really early in the universe's history, very early in the Milky Way's history. They are, really give us a deep dive into the past that we can't do with a lot of individual stars that we look at.
One cool thing that they've found evidence of in a few of these globulars is something that has been given the name blue straggler. And it's, when we seem to find a blue star, we go, we've seen
I'll
a
actually
blue star?
switch to this image quick. This is an image of a different globular cluster, Messier 5, taken with Hubble. It's a really close-in view of the core, and so I think it helps to really see some of those colors. And you can see there's quite a few blue stars in here, and they were not expecting that.
Yeah, so where some of these might come from is, well, you look at the density of the stars, what if they collide? And so if they collide, they're going to be more massive, more fuel available, they're going to heat up. And so they will become, that new star will be, or that collided star will become a blue star, where you might not have expected to find a blue star before. So that was a
Very
little bit of a surprise.
interesting. Yeah, really interesting.
Yeah.
I think another thing that this image really brings up for me, especially peering so deep into the concentrated core and having the clarity that Hubble does, is just how packed in these stars are, right? And this is something that really differentiates globular clusters from, kind of our area of the galaxy that we're used to, the kind of night sky that we're used to, right?
Yeah.
So across the Milky Way, and this includes areas all the way out where we are, kind of further out where stars are a little bit more dispersed, all the way to the center, the average distance between two stars is about 5 light years. Within the cores of these globular clusters, it can get down to the distance between the Earth and the Sun. That's the average distance between them. Absolutely, remarkably packed in, and that is actually what has helped these globular clusters hold their shape for so long.
Can you imagine what the sky looks like?
It's crazy, right? So the ones that we were looking at earlier, M13, I just saw this note in here. Or no, this was actually for M3, the bigger one, almost 700 light years wide. You could fit the entirety of M3 between us and Betelgeuse.
Yeah.
So Betelgeuse, very bright star in the sky, in the Orion constellation. Can't spot it right now because it's more of a winter constellation, but one that we're all very familiar with. Not a particularly close star, right? We saw the other one 37 light years away. Every single star, 500,000 of them, in between the distance between us and Betelgeuse.
Yeah.
Absolutely remarkable scale to consider, and it really does help them last longer, right? So these open clusters, they'll spread out over time, and they won't, appear as clusters anymore, whereas these globulars have held these spherical shapes for, over 11 billion years. It helps keep them very, very stable. And imagining what the inside of M13 here that we've got in view must be like is just absolutely mind-boggling to me. I mean, seeing so many stars that close together, they're the distance between us and the sun, but it's not like it's just two stars rotating around each other like we see with binaries. There's so many more surrounding them in every single direction.
Makes you wonder, do they even have a dark night?
Right. Is it dark at night? What kinds of planets can we really even have around a lot of these stars? We're starting to discover the first ones around some of them.
So there's a literature connection to this as well.
True.
And that literature connection is Dr. Isaac Asimov wrote a novel by the name of Nightfall. And it is about a planet that has 7 suns, and as in stars. And they're always up, but every 1,000 years or whatever it is, all the stars are on one side of the planet, and they get to experience night and what happens to people who never experience dark or natural dark. So anyway, if you're interested in science fiction, check out Isaac Asimov's Nightfall. It is a really good book. I read that when I was a kid.
We were just talking about it last night, actually, when we were looking at this through the telescope. Yep, one of the volunteers had brought it up and was chatting with some guests about it after they had looked through.
That's cool.
So,
we hadn't talked about that.
We just talked about it yesterday.
Oh, that's awesome. Should I try M5? I mean, we're 2 for 2 so far.
Yeah, I mean, we had one more globular cluster in mind for the night. We might as well give it a shot. If it doesn't work out, we've had a great night of observing. And if it does, great. M5. Yep, M5. And one last time with my new camera setup, just because I want to show off that it's still working. Oh, it's getting a little dark in here to make up the the telescope on the cable we're feeding.
Right. Great.
Perfect.
All right.
Alrighty. I'll wind up.
It's dim, but it's there.
Faintly in there. We'll see what kind of a view we can get. But I will say that this is the last object we had planned for the night. We're at about a 50-minute runtime so far. So if you have any questions related to globular clusters, now's the time to send them our way. As we admire the last one of the night. So as Michelle said before, or as we had mentioned before, this one is the 5th Messier object. This one is M5. And comparing it to some of the last ones, this one's about the same diameter as M13, actually about the same distance away from us as M13 as well. And really all these are about the same age. You know, what's 10.5 billion versus 11.5 billion years, really, you know. But this one we're a little more uncertain on the number of stars. It could be smaller, maybe as low as 100,000, but up to that same kind of 500,000 range. It's really where a lot of these kind of notable globular clusters sit in terms of number of stars.
It is, as Hunter said, the 5th thing on Charles Messier's fuzzy objects list. So Charles Messier was looking for comets. Did you mention that?
I was describing it when you were getting on our first globular of the night.
And so, can you imagine always just running across fuzzy things?
I mean, I know.
Is that one? No.
What blows me away is that it
No.
has become such a reliable list that people use for, there we go, a great view of it. And I think this one, another good comparison with M13, where we can see a lot more densely concentrated in the center and then not so much around the outer edges. Unlike M13, where we saw a nice big spread of all of them.
Let's see, I'm gonna move this slightly. Let's see, I want to go down.
But yeah, it always blows me away when I think about the Messier list and how he was actually making a list of things he wanted to avoid looking at, and it has become an almost de facto list of things that everybody wants to look at all the time now, particularly amateur astronomers. You know, people have their Messier marathons where they try to spot all 100 plus objects in one night. You know, it is such a de facto list now, and was really the opposite that Messier was intending when he created the list.
Exactly.
But he did a great job at finding fuzzy stuff, I gotta say. He found all the bright fuzzy things.
And he did find, I think, 13 comets. But nobody remembers him for that.
He found way more other than that.
Yeah.
How many Messier objects are there? 107?
There's 110.
110.
He didn't find 110 there, but there were objects that were added to the list later that he may have cataloged them, or he may have notated them, but not identified them as actual separate objects. So,
and you know what? While we're talking about it, we mentioned our volunteers. We have lots of telescope volunteers that help us out in here. And one of them sent me a really great picture yesterday that shows why Messier might have gotten confused between the two. We can actually see M3, which we started the evening with, beside Comet Leonard in 2021. So they were right together in the field of view of his. This was a smaller telescope taking a more wide, actually this might have even just been a DSLR, honestly, taking a wide field image, still long exposure that allows it to see more of that stuff, and taken from quite a dark side. I can't remember. This might be from Middle Fork where he took this, a dark site here in Illinois.
And by the way, we are going to be recruiting more telescope volunteers. So keep an eye out for the application for that. If you want to come volunteer at the Adler and learn how to operate our telescopes, hey, you could be one of our small scope folks showing people the sun. You could show folks really cool stuff.
Yeah, learn how to run this telescope.
Yeah, exactly.
Yeah, that'll be up on our site in the next couple of months. So keep an eye out for it. Well, is there anything that we've particularly missed about globulars I don't think so. I've mostly just been distracted by the great view, the new camera. Wow. But mostly the globular clusters.
I've been shocked that we actually got to show you all three.
I know. We were really nervous before the show. The whole hour while we were setting up out here, it had gone just horrible. It had gotten so cloudy, nothing but clouds above us. And it broke. I mean, you saw it breaking as we started when we were looking at Spica.
Yep.
Seeing it go from just a black screen to.
We got good luck here.
I know, we got good luck. We were actually going to do this on Tuesday night, and it was raining, so we switched to tonight instead.
Yeah.
So I'm glad that it worked out.
So, what have we learned? We've learned globulars are old, globulars are far, globulars are big.
Exactly.
Globulars have a lot of stars in them. Globulars are round. You might get to see one or more of these globulars if you visit us on a Wednesday night in the early summer or late spring. And if it's clear. By the way, the best way to keep in touch with that as to whether or not the observatory will be open on a Wednesday night or not.
Yes, great note.
Is check our scopes at the Adler Facebook page. So check that Facebook group. You can join the group. You'll get the updates as to when we make our determination on a Monday or Tuesday whether we can actually open on a Wednesday.
Yep.
So
we update our Wednesday night opening times because it does vary depending on sunset. We'll post any of our other observing programs that we do, like Scopes in the City in there.
Yep.
And it has kind of blossomed recently into a lovely little community of observing. I saw a lot of great aurora pictures from about a month ago, or however long ago that was. Time has been crazy since the eclipse. I can't tell anymore.
A little under a month ago,
When the aurora happened, we got tons of great pictures there, lots of good eclipse stories. So it's a nice place to come and share your love for astronomy and learn how you can come and observe with us sometime. So that's how you can see us in person. If you want to check out more of our shows in the future, we do all kinds of different shows. Sometimes it's about things like this, where we'll maybe choose a kind of object in the sky to look at, but sometimes it might be about more time-sensitive things like lunar and solar eclipses, comets that are in the sky, all kinds of stuff. So it's really exciting to come and join us at any of those shows.
In fact, our next show will be Tuesday, September 17th at 9 p.m. Central Time. Why? There is a partial lunar eclipse that evening. We want to show it to you from here at the observatory. Keep in mind, the observatory will not be open to the public that night because this eclipse, while partial solar eclipse, or partial lunar eclipse, sorry, I think I might have said partial solar, sorry, partial lunar eclipse, sounds really spectacular. This is not a spectacular partial lunar eclipse. The amount of the moon that will be shadowed in the Earth's shadow is relatively small, but we think it will look pretty cool through our telescope. So we want to show it to you.
Yeah, well, the moon looks great any old day, right?
Yeah.
And having an eclipse going on is just a good reason to look at it, right?
Exactly.
Or at least an extra good reason to look at it beyond the plethora of good ones it already provides.
Exactly. So 9 p.m. Central on Tuesday, September 17th, 2024, for a partial.
I'm so impressed you know what day of the week it is. That's incredible.
I nerd like that.
You impress me every day, Michelle.
Thank you.
So subscribe to the channel if you want to keep an eye out for those future live streams. Jennifer will also link a feedback survey in the chat. We love hearing feedback about the show, things you think we could do better, letting us know how awesome you think our new camera view is that we have. But also, I think most interestingly to me is also recommending potential show topics for the future.
Exactly.
So when we don't have stuff like a lunar eclipse going on, we'll sometimes go to there, see what people are looking for, what they're interested in observing, and we'll go ahead and try and show that stuff. So it's great to fill out and really helps us out with developing future shows.
We don't have our topics picked for 2025.
That's true.
Let us know. So we've got the lunar eclipse in September. We're keeping an eye on a possible interesting comet in October, so stay tuned for that. We're gonna hopefully show you Jupiter from the telescope in December, but after that we don't have the topics.
I know, got a lot of
send us some ideas.
lot of 2025 to think about.
We can't show you a black hole. I know you want us to. We can't. Nobody can. So it's not just our telescope. So while we would love to be able to do that, we can't. We get that suggestion all the time.
It comes into play if we're looking at galaxies or something. We can at least talk about them, you know.
Exactly.
Well, other than that, I think the big thing that we have is just a big thanks to everyone for joining us tonight. Big thanks to the clouds for clearing just in time so that we could view all three of these clusters. I mean, M5 is just looking spectacular up there right now. So thank you all for joining us today. Thanks Jennifer and Geza for helping us out in the chat. And we will see you guys next time. You know, usually we put up the end slide, but I kind of think we should leave with this spectacular view of M5 because it really does look so nice. Nice tonight. So thanks everybody. We will see you next time.
Thank you.